In this study, we can understand how the area, the definite integrals gives area under the function. Area under the function you can get. Let us consider f of x is a continuous function in a closed interval a comma b. Okay. Now in that interval means there is no gap here. There is an interval, closed interval. Let us we can this is a function where x is variable, x belongs to an closed interval a comma b. Okay, then what happens if you take a area function, if you define an area function from a to the x, note why we call that is area function. As x changes, this area from is, if suppose x is here, the area is this much, and x is like this, okay. From a to the x, where x is maybe anything between the a and b, x belongs to, as x changes, the area is going to changes. Therefore we call that as area function. It depends upon the area under that function, okay. Okay, now well and good. What we initially consider, we consider a function f of x which is continuous in a closed interval. Just we consider area function, okay. This is the initial setup. Now after that, now imagine we are going to take an area, a very small quantity. Means what we are taking, x here, this is area of a to x, this is represented by a of x plus h, and is sorry, this area is expressed by a of x, and if you extend it from x to the x plus h, whatever the area from a to the ax plus h is given by a of x plus h, and the whatever the gap is called, I can say that is represented by a of x plus h minus ax. This area we can call, this is represented by a of x plus h minus ax. Okay, this is represented. If you take a small, a tiny slice, we can say that whatever the area, we just take minute change in the x, what we are doing. Okay. Now in the steps 3, as h we are going to take very smaller quantity, then almost whenever the smaller quantity we can take, the we can say that both the sides of this act as a rectangular, the slide act as a rectangular perfect, whatever the thin slice is almost a rectangular shape with width h, and height is f of x. Therefore the area is equal to f of x into h. Now if I want to find out the rate of change, what we can do, we have to find out the rate of change at that particular point x. What is the rate of change? You are going to work out the rate of change of area at that particular point, maybe call that x. If you want to calculate, we have to calculate a of x plus h minus a of x divided by h is equal to approximately is equal to x here, f of x, because area is nothing but the, this area is nothing but the f of x into h. This, therefore we can call this as h tends to 0. If you work out that, that becomes a dash of x. Here what we are doing, we are going to find out the, whenever if you change the x from to the minute change in the x, whatever the change in the area means just point change in the h. If you work out that change in the area divided by h, what we are doing here, we are going to find out the rate of change of area at that particular point. That is called a dash of x. But what we get, it is, okay, whatever we calculating, we are going to find out the derivative of that. Means the change of area with respect to minute change in the x, as h tends to 0, we are, that is equal to what we get, that is equal to f of x we can get. Means what we conclude that whenever the area derivative of the given area function, area under that function, derivative of area at that function is equal to height of that function value. What we can get, this means the whole area, the area function, whatever this area derivative of area function we can get, derivative of area function at particular point called maybe x, which is equal to height of the function at that point. Keep in mind, height of the function. Now, what function here? The function is, we consider f of x here, under which we are taking area function. Okay, that is means, what is this actually? If you again means, a of x is what? See here, if you integrate it once, if you get a dash of x is equal to f of x, if you integrate it, what we can get? We can get anti-derivative of, means we are going to get antiderivative of f of x, that is g of x plus c. That therefore, whenever we conclude that a dash of x is equal to f of x, okay, once if you conclude, once we conclude that a dash of x means derivative of area function is equal to f of x, once if you integrate on both the sides, we can get what we get. We can get antiderivative of this function, that is called g of x plus c. Some, because it is not indefinite, it is indefinite integrals once a of x is equal to g of x. But as you know, see, if suppose if you put x is equal to 0 here, a of a, you know that whenever area from a to the a 0 here, a of a is equal to 0, by that we can conclude that c value, c what happens once we get this equation, no? A of x is equal to g of x plus c. Now, if you put x is equal to a here, what happens? We are going to find out the area from to the a itself. That is, a of x is 0 here, because a of a is equal to, because the area from a to a is 0. Therefore, we can solve this by c. We can calculate that is c is equal to minus of g of a. Now we can conclude that a of x is equal to g of x minus g of a. This is from step 6. Now, from the step 7, if I want to calculate area of B, what we can say? Area from B, okay. Area up to the B, okay. Area from A to the B, okay. We can calculate, that is from G of B, because A of x is equal to G of x minus A. Therefore, we can get G of B minus G of A. What we conclude, in order to get this one, directly we can say that is, if you, this one we can rewrite like this. See here, instead of writing, can you write a of x is equal to integration from f of t into dt? Once if you get it, what we can get? G of t minus g of, what happens here, g of uh, t from minus g of a from x to a. Once you equate the things, okay, what we can get, that is equal to g of t. If antiderivative of f of t is g of t, then if you apply this one, you can get finally g of x minus g of a, which is nothing but the like this. Okay, finally what we result arrive is integration of a of x from a to x f of t into dt. T here, t is a dummy variable here, just we are whatever, if you solve it, you can get like this only. You can just, we are using a t as a dummy variable, because why we are going to get here, because this value is equal to g of t, okay, in the interval of a to the x. Again, after substitution of this, becomes g of x minus g of a. This is how we can understand how this, I can say that the area function is nothing but the antiderivative of a given function. What we conclude that the area under that function, okay, is nothing but the antiderivative of that function, because see here, a of x is equal to g of x plus c, you can get like this, no? Which is nothing but the g of x is what? G of x is antiderivative of f of x, okay. Thereby you can conclude that area function under any function, under function, is nothing but the antiderivative function, provided the function should be continuous. There should not be any gap, all those things. This is how we can understand the things. Thank you very much. This is what fundamental theorem of calculus.